In many economic problems, we cannot simply maximize or minimize a function without any restriction. Several functions are subject to special constraints. For example, the utility maximization is subject to a budget. Thus, in this chapter, we will see constraint optimization using a specific method called Lagrange optimization. In order to understand the Lagrange optimization, we first need to learn about gradients. Let's consider z, which is a function of x and y. The gradient is represented by an inverse triangle next to the name of the function. Conceptually, the gradient represents the direction of improvement of the function at the specific point. Mathematically, the gradient of the function is a coordinate point. The first element is simply the partial derivative with respect to x, and the second element is the partial derivative with respect to y. Graphically, we can see the gradient in the following way. So we have here z as a function of x and y. The slope at point B is represented by this yellow line. Then the perpendicular arrow to that yellow line is the gradient. In this particular case, you can see that the direction goes towards the origin, which means that if we move to that direction, the value of the function will increase. In order to understand how we can compute the gradient, let's do these two examples, in which we need to find the gradient at the point x equals 1 and y equals 2 of the following two functions. First, let's find the gradient of the first function. Remember that the gradient is simply a point, and the first term is the partial derivative with respect to x, and then the partial derivative with respect to y is the second component. However, the difference is that here we will need to replace at the end with x equals 1 and y equals 2. So let's find first the partial derivative with respect to x. So here the constant part is 4 times derivative of x to the fourth with respect to x is 4x cubic plus the constant part here is 5y cubic times derivative of x squared with respect to x is simply 2x plus derivative of 8y plus 7 with respect to x is simply 0 because both terms do not contain x. So this is equals to 16x cubic plus 10xy cubic. Then we just need to replace the values for x equals 1 and y equals 2. So this is 16 times 1 to the cubic plus 10 times 1 times 2 to the third. Notice that here is 16 plus 2 to the third is 8 times 10 is 80. So the value of the partial derivative using x equals 1 and y equals 2 is 96. Now let's find the partial derivative with respect to y. The first term is 0 because it does not contain y, plus here the constant part is 5x squared times the derivative of y to the third with respect to y is 3y squared plus derivative of 8y with respect to y is 8, and then the derivative of the constant is simply 0. So this is 15x squared y squared plus 8. And then we just replace x equals 1, y equals 2. This is 15 times 1 squared times 2 squared plus 8. 2 squared is 4 times 15 times 1 squared is 60 plus 8. Then this means that this is 68. So our gradient is 96,68. Now, let's understand what this means. So here we have x and y. And notice that first, both elements in the gradient are positive. When we graph this specific function, we will obtain something like this. Then this is the point x equals 1, y equals 2. And here we have the slope. What we are doing here is notice that the x element is positive and the y element is positive. So that means that this one is going in that direction because the x component is positive and the y component was also positive. This means that the gradient goes in that direction, which means that every time that we go to the right and up, the function will increase in value. Now let's find the gradient of the second function. Remember that the gradient is a coordinate point in which the first element is a partial derivative with respect to x and the second element is a partial derivative with respect to y. Let's start with the partial derivative with respect to x. So here the constant part is 3 times derivative of x squared is 2x minus, notice that the constant part here is 5 log of y times the derivative of 1 over x is minus 1 over x squared plus 0. So this is equals to 6x minus times minus is plus 5 over x squared log of y. And then we replace the values with x equals 1 and y equals 2. So this is 6 times 1 plus 5 over 1 squared log of 2. Log of 2 is about 0.69, 31472 times 5 is about 3.47 plus 6. This will be 9.47, which is greater than 0. Now let's continue with the partial derivative with respect to y. So the first term, the derivative is 0 because it does not contain y. Then minus 5 over x, which is the constant part, times the derivative of log of y is 1 over y plus derivative of y with respect to y is 1. So this is equals to minus 5 over x times y plus 1. Again, we need to replace with x equals 1, y equals 2. So this is minus 5 divided by 1 times 2 plus 1. Minus 5 divided by 2 is minus 2.5 plus 1 is minus 1.5. Notice that this is less than 0. Graphically, let's see what happens. So here we have the function. Here is x and y. What it means that at the point 1, 2, the x component is positive, so we're going to the right, but the y component will be negative. So as you can see here, the x component is positive, but the y component is negative. This means that this is the direction of improvement of our function. If we go to the right and down, then our function will increase in value.